Hey guys, so today we're going to see the 33rd problem, which is a search and rotated sorted array. As you can see, this is a medium problem. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. Okay, so for example, the array is 0, 1, 2, 4, 5, 6, 7, and this has become 4, 5, 6, 7, 0, 1, 2. Okay, so if you see 0, the first position is at here. Right, from 0, 1, 2, it will be like a normal sorted array, and the 4, 5, 6, 7 is again a normal sorted array. It's just that it is rotated. Okay, you are given a target value to search. If found in the array, return its index, otherwise return -1. You may assume no duplicate exists in the array. Your algorithm's runtime complexity must be in the order of O of log n. So they themselves are explicitly saying that we should use binary search. Okay, so binary search gives you O of log n performance. So, and it is a sorted array which is rotated. As sorted array, whenever you give an element to be searched in a sorted array, we go for binary search. Here the array is bit sorted. Okay, let's see an example. So for example, nums is equal to 4, 5, 6, 7, 0, 1, 2, and target is equal to 0. And so 0 is at position 4. Okay, and if you see 4, 5, 6, 7, 0, 1, 2, and target is 3, and target is not there, right? 3 is not present in this array, so we're returning -1. So an important point that you should observe is that although the array is rotated, like for example here the array is rotated, right? 0, 1, 2 has come here, and 4, 5, 6, 7, basically from 4, 5, 6, 7 they've rotated it, and so 4, 5, 6, 7 has come front, and 0, 1, 2 is remaining as such. So anyhow, in a rotated array you see that there are two sorted halves. 4, 5, 6, 7 is a sorted half, and then 0, 1, 2 is another sorted half, right? So at this point if you see, if you observe 7 and 0, right, this is the only place where the previous element is greater than the next element. Apart from that, they are all in a sorted fashion. So using this, what you can do is you can calculate the mid element, and if the mid element is equal to the target, then you can return it. Otherwise, what you can do is you can compare the mid element with the start element. Let's say if our mid element is 7, okay, and if the start element is 4, okay, and if 4 is less than or equal to 7, right, then and if the target is within this, then we have to search only this half. Whereas if mid is not greater than or equal to I mean the start is not less than or equal to mid, then we have to search elsewhere. Okay, so that is the approach. I hope it's clear. Let's jump into the program. Okay, so let's declare certain variables. So I'm just going to have start is equal to 0, and I'm going to say end is equal to nums.length -1, and I'm just going to say mid is equal to 0. Okay, and while start, this is just equivalent to the normal binary search, while start is less than or equal to n. And if you're not able to find this particular target in the array, we are going to return -1. Okay, so you can just go ahead and return -1. Now within this, we'll calculate mid. Mid is nothing but start plus, to handle overflow cases, we will do n minus start by 2. Okay, and now we check if array, if nums of mid, if this is equal to our target. So we can directly go ahead and return mid, right? If not, right, else if nums of start, okay, if nums of start is less than or equal to nums of mid, in this condition, 4, 5, 6, 7 condition. So nums of start is less than or equal to nums of mid. Okay, and target is not equal to mid. Then we check if target is greater than or equal to nums of start and target is less than nums of mid. We have already checked whether target equal to mid. Obviously it's not equal, then only it will come to this condition, right? So target must be less than nums of mid. If this is the condition, and target is lying in the first half, so which means we have to adjust the end, right? So what you will do is end is equal to mid minus 1. If not, what you will do is, if this is not the case, it lies in the second half, so in this case you have to adjust the start, so this will be plus 1. Okay, and else this means target is not greater than or equal to nums of start, and basically it is lesser, right? And target is not less than nums of mid, so which means it lies in the second half. Now we have to check if target is greater than or equal to nums of mid. It will not be equal to mid, right? So you can just say it's, if it is lesser than, if it will not be equal to, because equal to we have already checked, so if it is greater than mid, right? And target is less than or equal to nums of high. So if it is lying in the second half, right? In this case, what we're going to do is we're just going to say start is equal to mid plus 1. If not, we're going to say end is equal to mid minus 1. Okay, so that's it. Oh, sorry, this is end. And it is accepted. So that's it, guys. Hope it was clear. Bye.